Hello, my name is John Hoover. I am the Marketing Director at Telabs, and I also am a Board Director with APOLAN, and I chair the Marketing Committee. I will be your moderator today, and I'm pleased that you joined. Glad to welcome you to this APOLAN webinar titled Passive Optical LAN, Design, Theory, Value, and Fact. We have 45 minutes of content, which will leave us plenty of time for Q&A at the end. When you have a question, please type it into the Zoom Q&A field you'll find at the bottom banner menu. We will answer as many questions as possible as time permits at the end of the webinar. This webinar is going to be recorded and it will be posted up on the APOLAN website. We will provide a link to view the webcast replay in a post-webinar email. With that, I've introduced myself. Let me go ahead and introduce our other speakers today. We have Brian Hansen from Alpha and Intersys Corporation. Brian is a Director of Enterprise Solutions with those companies, and he also is very active on the Technology Committee for APOLAN. Also with us today is Chad Hines. Chad is a Project Manager with IT Connect. He too is very active on the Technology Committee for APOLAN. We also have Matt Miller. Matt is Network Leader at AECOM, and he is our Board Chair of the association and also is very active on the Technology Committee. Today's agenda is very full. Glad to get through these topics. The first one's going to be what is Passive Optical LAN. Then we're going to move into how Passive Optical LAN technology works, network design theory, and we're going to walk through where Passive Optical LAN is being deployed in the marketplaces. And then at the end, like I said, we'll have good time to handle Q&A. So with that, let me go ahead and turn it over to Brian Hansen.
We wanted to start by painting the picture of the optical network as a whole for you guys. I'm sure you've heard terminology and the acronyms of GPON or PON before, and that's just acronyms used to describe the fiber network. We've been running fiber infrastructure for decades now, coming from the telco space and that central office in that OSP setting, bringing fiber to the prem, fiber to the home applications. So obviously this is a proven technology that we've had deployed and in use for decades. With a lot of us now working from home, kids at home, parents at home, you can understand the value and the use case of the passive optical network and providing fiber to either your DSLAM or your prem or your home because of our depth of bandwidth that's needed now. Passive optical LAN, we're really getting into now that local area network. So now we've moved past truly that OSP type setting, and we're focusing more on an ISP or campus style setting. It's traditionally thought of in the telco space as improving that reliability and resiliency to the network. With that quick overview, I'll pass over to Matt. We'll take a deeper dive into what is the passive optical LAN and some of the pieces of the puzzle.
Yeah, thanks, Brian. That is a great way to start off the presentation because it kind of gives us a history of this technology and kind of the roots of it. But what we're talking about today is specifically passive optical LAN, the application of that passive optical network technology in our LAN environment, applying it inside the building, essentially. So what you're seeing here is a simple diagram showing the components of a passive optical LAN. On the left side of the screen, we have our optical line terminal, or our OLT, and that's going to go at the head end of our network in a data center or an MDF, somewhere in the core of the network. And that OLT is going to have standard network connections coming into it, standard Ethernet connections at 1 gig, 10 gig, 40 gig, whatever your network dictates. Where we leave the OLT is where things change in a passive optical LAN from what we're used to. So coming out of that OLT, we're going to have single strands of single mode fiber. That's one strand of single mode fiber for each splitter that we see out in the center of our diagram. Those optical splitters take that single fiber and replicate it to most typically 32 fibers. And that's all done passively. That's where the passive and passive optical LAN comes from, is from those splitters. So we don't need power, we don't need cooling, and that means that we can put those splitters just about anywhere. We can put them in a traditional IDF if we have them and want them, but we don't necessarily need them. We could also put them in a zone box enclosure, under a floor, even buried underground, because we just don't have any environmental constraints. So leaving those splitters, right, we're going to have that one fiber that's now replicated to 32. Those individual strands of fiber leaving the splitters are going to go to our optical network terminals, or our ONTs. Those ONTs are going to be as close to the end user as possible, and they're going to convert that fiber to a usable interface for our endpoint device. That could be an Ethernet port, it could be multiple Ethernet ports, it could be a coaxial video connection, or even a analog POTS phone connection. So let's take a look at the next slide here. That's our optical splitter. So a little closer look at that. That's going to take that one fiber in, and like I said, most typically 32 out. And again, no power, no cooling required for that splitter. So we have a lot of flexibility in the placement of where that goes. It's going to replace the functionality of our switch though. So just imagine all those switches in our closets going away and being replaced with these devices which have no moving parts, no blinking lights, no environmental constraints. Most typically 1/32, but down to a split ratio of 1/2, or up to a split ratio of 1:64. And we can also have dual inputs if we desire that redundancy. So now let's look at the optical network terminals, or ONTs. And those really can take a lot of different form factors. Like I said, anything from one single Ethernet port up to multiple Ethernet ports, or even video and analog phone interfaces. You can see a variety of models here, but there's much more than even what we've pictured here. Most typically, we see a 4-port Ethernet, but they expand all the way up to 48 ports of Ethernet. And we can also have like I said, an RG6 connector with that coaxial video or analog phone. And we can have them in industrial housings. We can have them in faceplates. We can have them in rack-mounted closures, depending on what the endpoint device requires. So now we'll talk about how we power these devices, Brian.
So as Matt mentioned, in the closet or at your splitter location, yes, no power, but we do have active components within your passive optical LAN power architecture. That being the OLT at your head end, and then at the edge with the ONT, the optical network terminal. We see 3 main architectures that all start from the same, your local AC, and then they all finish the same, bringing a DC to power that electronic circuit. Let's remember that virtually all electronics use DC power for the direct power. As it provides, it's really a more stable current flow to your electronic device. So in the first block you can see here is we're using an external power supply, which is your converter. This is sometimes referred to as a wall wart or a power brick. You know, the example that you see here is that you like your laptop. So when you plug that into your AC outlet, there's a converter. There's a power brick that takes that into DC power that powers your device. In the second power block, you can see it's taking AC all the way to your edge electronic device or to your ONT. That's with an internal power supply built in. So you're running your AC direct input. This is something that you would think of maybe like your television at home, where you're taking a power cord from that AC, but your converter or your PSU is actually built into the electronic device, or the ONT in this case. You see that with a lot with our rack-mounted ONT type solutions. And last but not least, we're speaking towards remote line power now, which is taking the AC feed and we're moving it into a rectification or a rectifier DC plant, and then a class 2 type up converter. So it's taking a 48 volt, bringing that to a -57 in the majority of cases. And then that DC to DC through that up converter, or PDU, if you will send an elevated voltage down a copper conductor, and that will power the ONT directly.
So now we're going to get into a little more of the network architecture and design of our POL network here. Matt described a little bit of this. We're going to get a little bit more into it now. First, our POL system is only layer 2. We're not doing any layer 3 routing within our POL network. This is why you still see this core router above our OLT. This core router is still required for layer 3 for uplink to our voice, our video, our switch video, and data traffic. So from our core router, we're showing a fiber patch from this core router to an uplink interface in our OLT. This uplink interface can be a 1 gig or a 10 gig connection. It can be built in a lag, redundant, however your customer and however this is required on this project that you're working. Coming out of our OLT, as Matt had previously described, we have our single strand of glass feeding an optical splitter. Here we show a 1x32 connection. This could be, you know, whatever configuration of splitter that you're using, as long as we're reaching this minimum requirement of signal, DD signal at our ONT, which we'll describe a little bit later. Out of our optical splitter, you'll see we have our individual strands feeding out to our ONTs. This could be a 2-port, or I mean a 4-port, an 8-port, a 24-port, or a 48-port, as Matt mentioned earlier. Everything in between this OLT and this ONT is all a passive infrastructure. There's no power requirements in between this OLT and the ONT. The only power that would be required would be at the ONT, which Brian has been discussing. That could be done through a DC conversion or AC locally powered. What we're doing here is we're transmitting and we're receiving upstream and downstream across this single strand of fiber. How we're doing that is we're doing this at different wavelengths. So we're sending downstream at 1490 using TDM, and we're coming back upstream at 1310. When we get into, as Matt mentioned earlier, you can have a different configuration of ONT using analog RF video. When we get into RF video and these other types of services, you're going to need a WDM. And what the WDM is, it actually injects another wavelength into our network prior to the optical splitter. As you'll see, we send RF video only in the downstream direction at 1550. And this is how we get video services at the back end, at the ONT. When we get into 10 gig and even 40 gig, it actually works in the same manner. We just send these at different wavelengths across the same piece of glass. That ONT that's at the bottom end picks up that signal that it's looking for, and then it feeds that traffic. And what we're showing here is our optical splitter actually changed to a 2x32 splitter. And they're using that to actually inject that 10 gig wavelength into the rest of your fiber infrastructure. You'll also see that 10 gig fiber is actually coming out of a different line card in the OLT. It's coming out of an XGS port rather than your standard GPON port. This is great because now we're actually feeding our standard GPON and our XGS signals down a single strand of glass and through an optical splitter. This allows you to upgrade users as you see fit. So you could have an office next to you using a standard GPON signal, and then an XGS user in an office next door, maybe the boss, he requires his 10 gig. That's how our architecture in Passive Optical LAN is put together. When we get into design practices, the amount of flexibility and ways of designing is almost limitless. There's so much you can do, whether it be a completely fiber-fed distribution from your end user and your devices all the way back to your OLT. Everything is completely fiber optic. Versus maybe you're doing a retrofit and you're utilizing existing copper infrastructure and maybe just putting maybe some rack mounted ONTs inside your closet, and you're just kind of migrating them at a slower pace. You have your splitter placement. These can be in an IT room, as we've described, a ceiling enclosure in a closet. Matt mentioned you can put these pretty much anywhere. You'll see in the pictures to the right, we have some rack mounted options. And then you have, all the way to an enclosure to a cassette form. You have your AC and your DC remote line power and your battery backup options. All of these are going to kind of affect your design and the way you proceed. We have our POL distances and signal loss. You can go up to 20 kilometers, a little over 12 miles from your OLT, all the way down to your ONTs. And then from your ONT, you can still go another 300 feet or 100 meters in your copper. This is just, we're left to this 300 or this 100 meters. That's just due to our copper limitation that we're held to in these days, right? And then we have our ONT form factor. These could be wall-mounted ONTs recessed in the wall. It could be a cubicle form factor of ONT, maybe sitting on top of a desk, or just wall-mounted on a wall or in a closet space. They come in 4s, 8s, 24s, and 48s, as mentioned. Now, when we get into our splitter placement and what we do with our network here, we have our closet distribution, which, as I mentioned, is basically just home ran from your station end back to your IT closet into a typical four post or maybe a cabinet of some sort in your IT closet. This kind of follows our typical legacy way of cabling. Next, we have our zone distribution, which could either be in a ceiling enclosure like you see on our slide here, could be in maybe in a wall-mounted box in a closet somewhere, in a storage closet, or as Matt mentioned, these don't got to be IT closets anymore because it's completely passive. There's no large amounts of power needed for this infrastructure. We don't need any cooling for it, so we can virtually put these things anywhere. With a zone distribution, what we're doing is we're taking that single piece of fiber from our OLT, we're running that closer to our end user where we're going to put the splitter out there, and then we're cabling shorter runs to our ONTs. This might help with adds, moves, changes, as you see. And then we show different configurations of optical splitters. Matt mentions you have your 1x2s, your 1x4s, 8s. They make them in 1x16s and 32s and 64s, and then you can buy them in a 2x configuration for redundancy. We're going to hand this back over to Brian to kind of go over some of these powering options when you get into the design aspect.
You can see in the examples that are shown here, there's multiple types of ONTs powered in different ways. We've kind of alluded to different types. So you can see rack mounts, you can see in-wall placements, you can see them in drop-down ceiling boxes, in Soho boxes. It really depends a lot on the design of the project, of the application. So it's going to vary. The architecture is not one that fits all. It's not one size fits all in these types of scenarios. You really need to understand the facility, the costs that are associated with that, the current infrastructure that could potentially be available, and what you would need to upgrade to handle this type of system. HVAC, facility grounding, fire suppression. Is there even a footprint available in an IDF? Are there IDFs? Are there AC outlets or AC panels available? All these, all these are determined as to how you're going to build out your network or with your power options here. Other things that you want to consider with that is battery backup needed. What devices are being ran from your passive optical LAN, what you're tying into it. The quality of experience and service for a guest, if you will. All these things taken into consideration will help you lead down the path of what powering options you potentially would be able to use in those types of scenarios. That being said, we're going to bounce back to Chad here for distance and signal level on your passive optical LAN.
Yeah, thank you, Brian. So distance is where our POL technology really shines, right? As I mentioned, we can go up to 20 kilometers, a little over 12 miles from our OLT all the way out to our ONT. And then from our ONT, we can still go another 100 meters in copper out to our end device, be it a station, handset, camera, wireless, door access, whatever's requiring this connection. One thing to know is with better optics, you can actually go past that 12 miles, that 20 kilometers. So don't limit yourself to that. We can upgrade the optics in there and get you a little further if that's required. This awesome distance is why POL is so great for campus environments. You can have your OLT sitting in one building and then have your completely passive infrastructure feeding all the way out through the rest of your campus, and then house your optical splitters in each of the remaining facilities in your campus environment. This removes all that old legacy switching that would typically be in these other buildings. Now you're just taking a single strand of glass or multiple strands of glass if you have more users from these facilities back to your OLT sitting in a different building, and you just have splitters feeding all these other users through the rest of your campus. So with this incredible distance, of course, these lasers coming out are super hot. To blind you real quick, if you look at them, you'll see coming out of our OLT, we're at a plus 3 dB. We require a minimum of 15 dB loss. Once we get to our ONT, you'll see our operating range listed here is 12.5 to 26 dB. That's our functional operating range. How we get that 15 dB of loss, it's done through the splitter. That's why we kind of standardize on a 1x32. It kind of spits out that magical number, gives us what we require out of our ONT. Once we get into, we put a simple drawing together to kind of go over what this looks like on paper. This kind of gives you a better idea of what it looks like. To kind of hopefully eliminate some confusion if you have it. There's not a lot of moving parts when you put these systems together. It's actually fairly simple. You'll see we're going to start off on the left-hand side where the cursor is. We're coming out of our IT closet with a single strand of glass we show in yellow to our zone distribution box. All the purple lines feeding out of the zone distribution are just single strands of glass feeding all of the stations out of that optical splitter in that zone box. We put our orange triangles on there. That's just signifying a wall-mounted ONT sitting in our offices at our typical locations. From there, you'll also see we have an ONT with the blue rectangular shape. Now what that is just signifying a ceiling mounted ONT possibly. What that's doing is it's feeding all our overhead devices such as wireless. It's feeding our cameras, as I mentioned earlier, door access, really any of these ancillary devices that aren't physically at a wall. All of our ONTs are feeding power over Ethernet, even PoE+. So we're actually powering up these devices. Once you get into putting these ONTs in the ceiling and in remote areas feeding these overhead devices is kind of where you get into more of the remote power. Otherwise, you might need some local AC power in the ceiling. On the right-hand side of our drawing, you'll see we have our kind of typical legacy way of installing copper cabling, right? We're coming all the way from our end user, running a single strand of glass all the way back to our IT closet. And this is kind of where we get back into our rack mounted type of design. There's so many ways to put these together, where you put these splitters. There's really no wrong. I mean, there might be there's a wrong way to doing it. but there's so many different ways of doing it the right way. Whenever you get into doing your designs, make sure you consult with your manufacturers, either on the active equipment side or on the passive infrastructure side. They'll all help you kind of put designs together and distance calculations when you get into stuff, especially when you get in onto the power side. Brian will go over more now in terms of remote powering of these ONTs.
One of the power architectures that we have been using for passive optical LAN has been widely used throughout decades in the telecommunication industry, and that's DC remote line power. The theory behind it is you're utilizing a low voltage DC power. Think of it as PoE or beyond PoE, if you will. You're powering up a remote electronics. So you have a centralized power source. In this case, we'd be referring to your DC plant or your rectifier. In a lot of cases, the same location is that you would have your OLT or potentially splitters throughout the passive side of the network. From there, you're going to upconvert it to -57. You're going to send that feed out to the ONT. That feed is going to power up that electronic. Again, this is PoE without limitations. We don't have the limitations of your 100 meters when we're referring to direct power. You can see here an example of a hybrid cable where you do have 2-strand fiber as well as your copper conductor for your power pair. You can also split that up. There's no rhyme or reason to it. That's more of a dealer's choice on how they see that fit. Part of what gives us the availability to do this is NEC Class 2, and we'll cover the Article 725 very briefly here in the next slide. So what gives us the availability to do larger distances than what you would see in a PoE is that we do this under Article 725 of the National Electric Code. The benefit of this is it's a Class 2 circuit, and it's considered safe from fire initiation from shock. One of the major requirements that you can see is that it's current limited at 60 volts or less and power limited at 100 watts or 100 VA or less. When you follow a Class 2 requirement, you can now install this remote power cabling with a low voltage tech. You don't need an electrician, you don't need to have conduit or metal clad or an armored cable. You're able to do this very cost effectively. This is trying to obviously utilize the teams that are in place without having to spend additional CapEx to bring power to these locations. Again, one of the benefits leading to remote DC line power versus a traditional AC. Another takeaway from this and the NEC in regards to this Class 2 power is that your power level of that 100 VA or 100 watts has to be maintained when a primary protection device is bypassed. So essentially what that's meaning is that you can have an isolated circuit or another form of a secondary protection, and this will really eliminate the use of like fuse panels or a breaker panel in this application, steering you down the path of using a true Class 2 approved and certified PDU or DC to DC up converter, if you will. Now we'll go into 2 examples of really how the architecture is laid out throughout a building. So in this first example, you can see it's distributed DC. When designing remote power, you really need to understand the requirements, what your loads are, i.e. how much power you need to bring to your edge device, the ONT in this case, the distances thereof, how far from your power source you would be going to the edge, to that ONT, and quantities, really. When your quantities are much larger, obviously it's going to help steer you in certain paths because you might want to home run so many cables. And then obviously looking at the floor plan. This is going to help you make your choices in your architecture very simply. First of which is this distributed DC is breaking up your power locations throughout the build. So as Chad was referring to zone locations earlier, you could break up your power in the same theory. So you would have a zone location where you would have your power. Again, benefit when you have high quantities of ONTs and distances where you necessarily don't want to home run all these runs back to a main head end, freeing up a little bit more pathway to use multiple power locations. This example you can see here, we've got every 3 floors, we've got a power system. Or in the case of the zone, you could say every zone location, I would have a power system. The power system could consist of your DC plant, your class 2 PDU, obviously for sure, and potentially battery backup. That could be in the form of tying batteries directly into a DC plant, which is extremely efficient. Or you could also use UPS or a building UPS approved circuit that you could tie the plant to. In the next type of architecture we look at is really, it's a centralized DC footprint. So you have one main power location. You have one main battery location. So now that you've centralized your main DC plant and your battery plant and or UPS or building UPS, from there you'd be home, you could potentially home run your class 2 power runs to that location, or you can send out a class 1 power feed in some riser duct or conduit. And then you can have still break out class 2 PDUs throughout those locations. So you can still run almost a hybrid distributed type architecture while still allowing your main power plant and battery plant. Obviously, that's centralizing it. You're going to have a freed up CapEx and a freed up OpEx from less equipment and less management and maintenance after the fact. An example of this that Chad showed earlier is a drop-down ceiling box. That there was a splitter, there was a power system, all in that drop-down ceiling box that was being fed from a class 1 circuit from a centralized plant. Obviously, you couldn't fit a UPS and a DC plant or batteries up in that ceiling drop-down box. So in this case, we're just run a class 1 circuit to it. When we break down the actual architectures of this, it's the theory behind it is financial assets. So you can see on the next slide, there's a lot of agreement that we can say that passive optical LAN and fiber in general is a financial asset. Having that network is a very important asset that you can leverage in a build. So when we get into it, separating it, obviously a lot of infrastructure that is rolled out can either be sold as a CapEx or OpEx. There's a lot of value with passive optical LAN in general with both, and there's a lot of value in DC remote line power with both. So having these assets, I mean, we look at fiber being an asset. Well, power can also be an asset for your network, especially when you're comparing apples to apples of the true facility, understanding the costs that are associated. As we mentioned previously, CapEx, you can dodge the electrician costs, you can get out of conduit costs, which can be very expensive for any build. You can centralize your backup locations and utilize DC power like the telecommunication industry, really making a higher level of efficiency. You can converge a lot of your power needs in that building into a DC infrastructure, right? We hinted at earlier, electronics, for the most part, we're talking about a DC feed. So we're really starting to see from a CapEx an enormous amount of facility cost savings when we're comparing apples to apples. On the operating expenditure, now you've freed up potential maintenance concerns because of your battery and electronic replacements. And you're really giving that resiliency of that telecommunication grade system to this. You've got remote accessibility. Your first step of troubleshooting can be done with an Ieee interface through a controller. Now your electrical and building efficiencies, you can lower the actual utility bill by utilizing DC power, which is more efficient than AC power. And then obviously building out that network, the same as a fiber side of passive optical LAN, you've really future-proofed your asset. One of the other values that you'll see from this is centralized management from the active component side. Matt's going to dive a little deeper into that.
So one of the potential concerns we sometimes hear is about managing so many devices. We have all these ONTs that we need to manage, but it's actually quite the opposite. In fact, when we provision these systems, the ONTs are all managed by the OLT via a standard management protocol. So they actually act as one unit that's managed all by the OLT. And if we have multiple OLTs, we can actually have those all tied together through a single management platform. And that's what you're seeing here is the management platform from a few different manufacturers. They all have their own software that you use to manage all of the OLTs. But they all have that central management functionality, a single pane of glass that allows you to view your entire network from one place. So I can actually dive down into the management software and look at a individual OLT and the line cards and all of the ONTs that are connected to those line cards all from one place. So I can provision an Ethernet port from an ONT in a specific room all via that one OLT and the single pane of glass central management that's provided there. So it really all ties it all together and gives me that intelligence down to the desk level as to where things are in my network. And that kind of leads us to our next slide about the Internet of Things and all these devices that were connected. Brian?
When we speak to the converging of the networks, right, we're taking multiple networks in a building and we're converging them over PON. We're really cutting the constraints of traditional copper, right? Distances, bandwidth, the issues that you see with copper, we're trying to remove those with passive optical LAN. We open the door to all these devices, right? These electronic DC-fed devices. Obvious targets, right? Wi-Fi, CCTV and physical security, VoIP. But you start really finding a lot more benefits to this really as you start to take a deeper dive, right? With virtually all these electronics as DC, now we're getting into smart buildings, that building automation, LED lighting, smart harvesting, smart speakers such as the Amazon Echo and Amazon platform and Google platform with Home. Your AV, your audio-visual systems, this can all be ran from your passive optical LAN. When we start looking outside of even further outside the box, what we're seeing is private LTE, 5G networks, CBRS, this all having benefit from being utilized through passive optical LAN's technologies. I recently was in a presentation where they were talking about thermal heat mapping in the building. They brought up sterilization, which obviously is at the foreground of the pandemic that we've recently had to fight with COVID-19. And they were talking about how they have cleaning crews throughout their facilities nightly sterilizing. Well, putting heat mapping over passive optical LAN, they found that they were able to follow where people touched and where people were in, so they could limit what they were sterilizing. So there's a lot of things, if you look outside the box, that's why we kind of point and hint towards endless possibilities. You really can find multiple use cases for this. What we did is we wanted to cover some of the major use cases that we've been attacking for decades in passive optical LAN. We'll kick off with Matt and the government side of the house.
The government was one of the first installations of passive optical LAN, taking that PON technology and applying it into the LAN. And the reason for that was the security. Government installations that have that high security requirement often require fiber rather than copper, because fiber is inherently more secure. It's much more difficult to tap than copper. So just the fact that it uses fiber makes it more secure. There's also a lot of other pieces that make the technology more secure. So the government likes it for those reasons. We see it used a lot in the intelligence community, in military installations, and even local governments where they have a distributed campus or multiple buildings that have distance limitations, right? I worked on a Department of Homeland Security installation that utilized the technology not only for the security, but also because they were building on a historic campus where there were buildings that had to be preserved due to their historical nature. And we didn't have the pathways or the IDF closets because the buildings were 100 years old, right? They had no planning for big bundles of cable and massive power consumption in closets, right? They might not even had closets. So that's also another application where we see government and other industries. But I'll have Brian tell you about healthcare now.
Running in the same lines as you know, with government from a security standpoint, obviously a little different, you know, than a DoD or a DHS type application, but you do have security concerns within healthcare, right? Mainly the HIPAA compliance. The security of passive optical LAN is obviously a major benefit within this market. Once you start looking at your footprint, right? The high density demands, and you're looking at the TIA 1179, you're looking at potentially freeing up space on that floor plan, on that footprint, to focus on revenue. Anyone who works in the healthcare industries, you know, alongside with these partners today, can tell you that, you know, they've taken a huge dip because of, you know, canceling elective surgeries and things of that nature. So there is revenue that is needed from there. One of the main benefits you see from a fiber or an optical infrastructure is obviously that the interference that you would see with a traditionally EMI, RFI concerns with the copper. One of the applications that we've been very successful in utilizing within the healthcare space is access for remote connectivity. We found that in a lot of ERs specifically, by being able to log in remotely and manage, whether that be cycling the power or managing your layer 2, without sending a technician actually in there, you've saved thousands of dollars from having to re-sterilize the room after a technician was done at site. And then, you know, alluding to that, the campus setting, most of our hospitals now are campus. Passive optical LAN, as Chad mentioned previously, now you've got distance limitations that are no longer a factor for us, especially when you're talking about 12-mile runs potentially. You're covering that complete campus, all multiple buildings without seeing it. And then obviously looking at it from the patient side of the house, you can improve the quality of experience for the patient. You know, and that could be as simple as providing resilient and reliable Wi-Fi. And then obviously the privacy thereof. You can put your ONTs in the hallway, feeding devices to the room, where you wouldn't have to have a technician actually enter the patient's room, giving them the privacy and the experience that any hospital would want to benefit from. With rolling into that and the quality of experience, we'll dive into hospitality, which Chad will take.
Yeah, so the hospitality market is one we can probably all say is the most heavily adopted right now. Some chains have standardized on POL systems for all remodels and new installations. What they're getting most out of it is, you know, they're reducing this footprint and that distance. They're taking advantage of that distance. When you look at hotels of 300, 200, 400 room hotels, where they were typically installing 4, maybe 5 pieces of copper to each of these hotel suites back to an IT closet, where they would have their switches, their cooling units. Now, instead of having those IT closets on every floor feeding all these hotel rooms, they're taking POL and putting IT closets, let's say, on every 3rd or 4th floor. They're putting the splitters on these floors and then feeding out further distances with a single strand of glass to each individual room. And in some cases, they're actually sharing an ONT, possibly an 8-port ONT, between 2 rooms. And they put these ONTs in the closet. You don't even ever see them. They put them in little Soho boxes in the ceilings. One thing to consider is with hospitality now, they're making it more personalized, right? They're putting private Wi-Fi connections in each hotel room. Some of them are even streaming your own Netflix profiles if you have that set up on your account. So there's a lot more technology being pumped into the hospitality market, and how they're doing that and compensating for that is with a better network connection, and that's with POL. Even outside of the guest rooms, they're moving this into all the back of the house security, taking care of all the cameras. The wireless in these hotel rooms there's so much wireless going on in them. And with the more network connections, the more cost savings we get. And the hospitality market is big on anything to reduce costs and the footprint of our IT space. And next, we're going to go over kind of the education market. This is another one that's big on cost savings and the footprint. This is a big one in terms of our campus environment, where our passive optical LAN really shines, right? This is a really large market. We're seeing a lot of K through 12, a lot of higher ed adopting this space. They're taking advantage of the footprint, the space requirements, eliminating these IT closets. They're getting a stronger and more reliable network, where they would typically have students creating loops and affecting our network. Now we're fighting back with a better network and settings. Cost savings. The education market is seeing cost savings on new builds and remodels in terms of infrastructure. As I mentioned, once we get into a campus environment, we have a single OLT or maybe two of them for redundancy in our higher ed installations. Then we're feeding only a passive infrastructure, eliminating all our legacy switches that were existing in place. We're removing all of those, installing just a single mode infrastructure throughout these educational facilities. A lot of the education uses zone distribution. Some of them kind of prefer it. In some cases, they just kind of have a wing of classrooms where they don't have a closet, so they're putting in just a zone box, putting an optical splitter in there, maybe a remote power PDU, and they're feeding all of these classrooms and devices in these individual wings. They're not requiring these, needing an IT closet everywhere they start building out. We're able to reduce that footprint. This is what allows the education market to look so good. And the higher ed is really taking advantage of that 12-mile distance, where you have huge campuses just feeding all out. So the education market is a really big growing market for POL systems. We'll go back to Matt for enterprise.
Yeah, enterprise and commercial spaces are the last one we'll talk to you about, where we see this technology really picking up. And they're converging a lot of different technologies in these spaces, right? You got your voice, data, your video, your building management systems, probably 3 other systems I haven't named, right? Converging those all on one network securely is a big deal in those spaces. The amount of money we can save by having one single network deliver all that connectivity is important. And of course, the cost savings is important for everybody, right? That's easy to see. But when we look forward, we hesitate to say future-proof, but at least the future resistance of this technology, not having to go back in 5 years and replace with the next category cable technology, and instead having that single-mode fiber that will serve you for decades. That's a big deal when we think about cost savings into the future. And on that note, I'll talk to you about some cost savings that we see in various size installations here. So this is what we often see in various sizes of installations, from a small building up to a campus installation, looking at the various components that make up the costs of those. And just as a comparison, we've got our POL parameters, our passive optical LAN parameters, 4-port PoE ONTs in a cubicle environment where we're sharing them, 2x32 splitters, and we're using zone boxes, versus the traditional network where we're using 48-port PoE switches with a 10 gig uplink. You can see the various components that make up those costs. We have our active components, which would be the ONT and the OLT versus the Ethernet switches. We have our cabling components. Contrary to what most people believe, single mode fiber is actually very inexpensive. On a per foot basis, it's much less expensive than copper Ethernet and can be very easy to install. So the cabling and the labor associated with installing those is actually typically lower. And then lastly is the facilities costs, which we can completely eliminate with passive optical LAN potentially, at a very minimum reduce, but certainly the option to get rid of them completely is out there. So as you can see, as we go and scale into the larger installations, the savings continues to increase. So with that, I will hand it back to John Hoover.
Thank you, Matt. Thank you, Brian, and thank you, Chad. We're going to get into the Q&A portion of this webinar. I will ask you all to type in your questions in the field in the Zoom banner, And just to give you a little time to start typing, let me quickly go through a little bit about the Association for Passive Optical LAN. This group advocates for the global adoption of passive optical networks for use within enterprise local area networks. We are focused on formulating solutions on how to best market, design, install, educate, and support this technology. We are comprised of 30 leading manufacturers, distributors, integrators, installers, and consulting companies who are actively involved in promoting enterprise passive optical LAN. This is an invitation for you all to join us, get involved, and if you do so, you can impact industry research. You can get involved in events and trainings and webinars just like this one. I'm so pleased we had over 400 registrants for this webinar today. Influence association news and social media that gets pushed out, and we consistently get articles published in major media outlets, and you can be a part of that by joining this association. So I can see lots of people typing. So we got 10 minutes. Let me just get right into the questions, and I'll try to move these around to our speakers. So first off, Brian, I think this one goes to you. It's about DC remote powering infrastructure is an asset similar to fiber. Do you run dark copper like dark fiber? That's a good question.
Sure, yeah. In theory, yes. The idea is that you have room for your power needs for the future growth of it. DC power in general, and really why it was heavily adapted immediately into the telecommunications space, is really the modular design of it. You can grow very easily as your network grows, as subscribers grow in the traditional telecommunications space. So yeah, during initial install, instead of running, let's say, a 16.2 type cable to your node location or where your edge or ONT would be, you could provide additional pairs. And then as the power system grows, or as you add potentially ONTs or new devices to it, especially when we're talking about these increases of PoE, PoE+, PoE++, PoE++, whatever the future holds, you're getting more power-hungry devices. You're adding new devices. You're adding new things to this common converged infrastructure. So yes, you can run dark pairs of copper, just like you would dark fiber, to that node location. As it grows, your infrastructure doesn't need to be upgraded. You would just add modulars to the power system itself as you add devices to the ONT.
Okay, good answer, Brian. Chad, I'll throw this one at you. Does passive optical networking work over multi-mode fiber?
Yeah, thank you, John. In short, yes and no at the same time, right? We're primarily a single mode infrastructure, and this question is more manufacturer and equipment specific. There's one manufacturer that does have a multi-mode converter, but with that, you're held to distance limitations and port capacity than you would be on a typical single mode connection. Our best recommendation would be to recommend and install new single mode fiber if possible, and then consult your manufacturers to see what's available.
Okay, Matt, since you covered the cost comparison, I'll give this one to you. What is the smallest installation of passive optical LAN that makes sense?
Yeah, that's a good question. We get that one fairly often because we talked about some of the cost savings earlier, but sometimes we get the question, how small does it scale down? It sounds like that's what this is. Typically somewhere in the 150 users or drops range is where we start to see the significant cost savings of passive optical LAN shine, but depending on the application, it could be more or less.
Okay. I got a power one for you, Brian. If the building has existing UPS and eGen, won't that cover my backup?
Well, the purpose of an emergency generator or an eGen, as you put it, and a building UPS, traditionally those are sized out for the emergency scenarios of the building, i.e. your emergency lighting, exit signs, other what they would deem critical facility systems. Adding to that is sometimes not possible, really, especially if you're adding large loads to it. If you're building out a significant converging of networks over passive optical LAN, obviously getting your value from that, you might not have that availability to cover that in the load. You might not have those circuits already pulled at those locations where you can actually tie your devices to PON to it. Anyone who manages a facility can tell you that preventative maintenance costs on eGen and building UPS are much higher, and that's even if it's being done at all, than a traditional DC and battery plant. So I mean, that's one of the reasons why we always recommend to at least add runtime to your passive optical LAN to where you can cover that time that's allocated for the facility to be evacuated. I hope that covers that.
Okay. And Chad, I'm going to blend two questions together for you because I think we can knock these out in one answer. One was asking about, well, which passive optical LAN design do you see the most? And then the other one was asking, what are the key factors in determining which direction and design you go with passive optical LAN?
Yeah, no, those are great questions. To start, we see an even amount of both a closet and a zone-fed distribution system. I think it more depends on maybe the vertical market, possibly the customer that you're working with. Some of them really do prefer a zone distribution. We've worked with some in the education that they fight for that zone distribution box because of these adds, moves, and changes that they do so often. It just gives them a little more mobility. But then you look at the hospitality market where they're only utilizing a single IT closet for multiple floors. They're going up 3 floors and then they're going down another 3 floors. They're feeding 6 floors off of a single IT closet. Once you get into the PoE side of things and powering up your ONTs themselves, possibly remote power, that's kind of where we'll more so recommend an IT closet fed distribution system. You're going to get more capability out of your remote power system in terms of distances. It'll add more accessibility to the system. But if you're just running a passive infrastructure with an optical splitter, there's no reason to have an accessible zone box somewhere that's easily maintained. Once you get into the key factors of determining how you put your design together, there's different things to consider. PoE is a really big one. Like I said, if you get into remote powering of your system, that might keep you to a closet fed distribution network. The manufacturer that you're working with on the passive side, make sure you research their product line and see how their parts and pieces, their optical splitters, whether it be a cassette form that sits in a wall cabinet, tiny little fiber housing, that'll kind of help determine how all your parts and pieces are going to go together on your network side of things.
Okay, we got 2 more minutes. Let me see if I can find some good ones. Here's an acronym question, and I'll give this one to Matt. What is the difference between GPON, PON, and POL?
Yeah, we get that question a lot because we do have a acronym problem in this industry. So GPON is a specific standard of PON technology. And there's multiple standards bodies out there, but GPON is the most widely adopted one and one that we hear people refer to this technology as. PON refers to the technology as a whole, whether that's for fiber to the home, fiber to the edge, or for passive optical LAN, which is the specific application of that technology in the LAN environment, so POL.
And Matt, how about you just keep talking with this question, because somebody asked the plans for 10 gig XGS PON, NG and PON2, where does that all fit in?
Yeah, right. So most prevalent is that GPON standard, which is 2.5 gig. We see that used the most today because it satisfies today's needs. But as we go into the future, we can use that same single mode fiber, the same splitters, to go to 10 gig, which is XGS-PON. And then beyond that, we also have NG-PON 2, which is a 40 gig standard. So again, using that same single mode fiber, same splitters, we can now scale up to 40 gigs out to the endpoint device.
Mhm. And then there's the IEEE standards with the Epon also to all keep an eye on too. Okay, we're at the top of the hour. I want to be very respectful of everyone's time. First, I want to thank Brian, Chad, and Matt for providing some great content today. I also want to thank you all for joining this webinar today. Like I mentioned earlier, watch for a post-webinar email where I'll provide a link to the replay of this webinar that you can share with your colleagues. And with that, I'd like to wish you all have a great day and a great rest of your week.